Hello, my name is Said Tabatabai, and this is my second lab report presentation regarding the charge tapes. I'm going to be going over the purposes and the goals of the lab, the fundamental concepts used in the lab, the assumptions that we had to take into account, and the procedure of the lab. And then after that, I'm going to be moving on to the calculations regarding the amount of electric charge present on the tape. This week's lab is basically of continuation of the first lab that we had, but the goal is to use a different method of obtaining the amount of electric charge on the U-tape. Instead of assuming that the whole tape acts as a point charge, we are dividing the tape into small segments and treating each segment as a line charge. The overall purpose of this lab is to further widen our range of knowledge regarding how charged objects behave in real-life circumstances under less assumptions. For this week's lab, we're going to be using four main fundamental concepts. The first one being the Coulomb's law that we use for calculating electric fields and charges. It states that the electric force is equal to K times Q1 Q2 over R squared. The second fundamental concept that we're going to be using is the Newton's second law, which states that force equals mass times acceleration. We're also going to be using Newton's third law, which states that every action has an equal but opposite reaction. In this case, it's the electric force and gravity. And the most important concept that we're going to be using today is the concept of superposition. We're going to be using it by dividing the tape into small segments and then summing up their electric fields to arrive at a net electric field. There are certain assumptions that we need to take into account to make our calculations for the electric field and electric force much easier. First off, air resistance is negligible and can be ignored. Each U-tape has the same amount of charge and it is distributed equally along the tape. Each segment of the tape has the same amount of charge, and the sum of the segments' charges will be equal to the total charge of the tape. We also have to assume that gravity and the electric force are the only forces acting upon the tape. The procedures of this lab are basically the same procedures as the first lab. We began by creating a U-shaped tape and attached it to the side of the table with minimal contact using a base tape. The U-tape basically has a positive charge. After I held my hand, which is a neutral object, close to the tape, it got attracted to my hand. Then I made a pen negatively charged by rubbing it with a piece of cotton and then held it next to the charged tape. For the second part of the experiment, I made two U-tapes and tried to make one float using the other one. At last, I measured the distance between the tapes at the moment that the upper U-tape started floating. These are my observations from the first lab. The length of the piece of tape was 0.2 meters. The width of the piece of tape was 0.019 meters. The conversion factor was 1 gram per meter of tape. The distance between the flowing tapes was 0.016 meters. The tape got attracted by the pen and the tapes repel each other. The mass of the tape was about 0.0002 kilograms, and the estimated net charge on the tape from the previous lab is shown what is on the slide. And this is a screenshot of my glow script code for this lab. The main difference between this lab and the previous lab is that in this lab, instead of assuming that the tape is a point charge, we assume each segment to be a line charge, and we calculated the electric field using both x and y directions instead of just using the y direction. And as you can see, the magnitude of the electric force differs from the magnitude of the gravitational force, which points to the fact that there may have been some errors during the procedure of the experiment. There may have been a discharge or other complications. The total charge on the tape came out to be 5.1347 times 10 to the power of negative 8 coulombs, which is a magnitude higher than the previous results. And at the end, we got some questions regarding the difference between our results. What if you had modeled each of your tapes as a single point charge like the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. As you can see, the results differ by one order of magnitude, which is significantly high, and that's due to the fact that assuming that the tape is in an infinite amount of line charges gives you a more accurate result regarding the amount of charge present on the tape. The second question is, why do these estimates differ? Just like I said, the point charge calculation is solely based on the y direction, while the y line charge calculation took both x and y direction into consideration. In addition to that, since we are calculating segment by segment, the second method is more accurate since we're adding up using the concept of superposition. And this was my results for the second lab, and I hope that you enjoyed it. Thank you.